Hello my friends, this time I want us to look at relations, mappings and functions for grade 9s, and I hope we get something from the lesson that we have for today. Make sure you remember to subscribe and share so that we have a lot of people joining us so that we can all learn. Okay, so I've put down some definitions here. A relation is a pairing of elements from one set, set A to set B. So when you have two sets and the elements in there, members of those sets are paired, then you have a relation. And here's an example here. So we have two sets A and B, and here we have 1, 2, 3, and here we have 4, 5, 6, 7. So you can see the pairings that are shown by these arrow diagrams, these arrows here. So 1 is paired to 4, 2 and 5 are paired, 3 is paired to 6, and 7 is not paired to any number. So this is an example of a relation. And when you are looking at something like this, there are some important things that we need to learn from here. The first one is that the first set here is known as the domain. And we usually use the letter X to represent the domain. So it's known as the set of X elements. The first numbers that you mention are in the domain. And then B is usually called the range. Okay, the special name that we give to B is the range. And we usually use the letter Y. We use the letter Y for the range, and therefore we have this diagram here. So when you look at the way the numbers are paired here, the elements are paired here. So for example, you have 1 to 4, 2 to 5. You immediately notice something here even by not using any formula. You can see that here there's a number that we are adding to get this one. Even here we are adding a certain number to get this one. And the number is the same. So we call that a rule. It's a rule, a function. So a rule that we are using here, you can see that we are adding 3 plus 3. So here the values of A, 1, 2 and 3, we are adding 3 to get that one there. So the rule would be, for us to get this rule, we would say B is equal to, or you can even use an arrow there, is equal to A plus 3. So this A here represents all the numbers that are here. So when you add 3 to each of the numbers here, that's when we are getting the numbers that we have in B, and this is the way it is here. So B, or the numbers in B are found by adding the numbers that are in A plus 3. Just by looking, we can tell. So if we want to find a partner for 7 here, we just find the number that we can add 3 to, and then we get 7. Or we can say 7 minus 3, and then we get 4 there. So we usually represent these functions by these relations. Okay, so a special type of a relation that we have is called a mapping. A mapping is a relation in which every element of the set A, so every element of the set A, this set here, is paired to only one element in the other set. So here's an example here. 1 is paired to only 5 there. 2 is paired to 7. 3 is also paired to 7. So this is an example of a mapping. But if you change things here and say, okay, we are going to have 1, 2, 3, and then you do this. And then this side we have maybe 5, 6, 7. And then you say, okay, we are pairing like this. And then you say this one goes there, and then also there, like this. This is not a mapping, because one element here is mapped to 2 there, and the instructions are saying a relation in which every element of the set A is paired to only one element in the set B. Okay, so each and every element here should be paired. Here 3 is not paired, so this can't be a mapping. So this one is not a mapping. Okay, so this is just a special type of a relation. Now, there are so many types of relations. Now, in this lesson, we are not going to look at the types of relations that are there. Okay, we are not going to look at the types that are there. We'll just look at certain things that we have for today, and then we can continue. Okay, so let's look at our first question here. So the first question says C is equal to 1, 2, 3, and X is a member of C. If the mapping from C to D is such that Y is mapped onto X plus 2, find the set D. Find the set D and draw the arrow diagram. So here's how we are going to find the set D. So the rule that we are using to find the set D is this one here. So we have C here, we have 1, 2, 3. This is what we have here. And the rule that we are using is X plus 2. So X is what represents the members of this set C. So we are going to be substituting X here with these numbers that we have. So for us to find D here, I'll put D here. Let me even do this. We are going to be adding. So for the first one here, we are going to have 1 plus, here where there's X you put a 1, plus 2. And then what you get this side, 1 plus 2 is 3. And then here again you do this, you are going to have, where there's X now, you replace it with this 2. You are going to have 2 plus 2, which will give you 4. And then here, you have 3. So you are going to add 3, where there's X, you put 3 here plus 2, and then you are going to get 5. Okay, so this is our arrow diagram. The question which says draw the arrow diagram. And so the set D is given by the members 3, 4, and 5. So these are the elements of the set D. So this is the rule that you use. You just substitute where there's X there, you replace with the numbers you're given, and you have your set. Okay, so we can continue. Let's look at finding equations now. Okay, finding equations, and also not only finding equations but also functions. Okay, so here is what we are looking at now. We are going to call it equations and functions. Okay, equations and functions. Okay, so to find, we'll start with the equation. To find the equation or rule, as we are calling it, we called it a rule here, this one here. Okay, here in this example we are looking at how to use the equation or the rule. Now we are going to look at how to find it. So to find the equation or rule that relates two sets X and Y, we use Y is equal to mx plus c. Okay, this is a very important equation that we use here. So let's look at some questions or examples that will help us to understand this. So now the first one says the set of ordered pairs below shows corresponding values of X and Y. Okay, so we have 1,3, 2,5, 3,7, 4,9, and 21, K. Okay, so we are saying find the first one, find the function that describes the relationship. The function that describes the relationship between X and Y. And then the next question, number two, we are saying find the value of k. Find the value of k. Okay, so let's look at this question here. Let's look at this question. Okay, so we are now going to see how to find the function or the relationship between x and y. The relationship between x and y. Okay, so I'll start by drawing the arrow diagram here. Of course, you don't have to draw it, but I want to show it for ease of understanding, so that we can easily understand what we have. Okay, so here's what we have. We have these values here: 1,3, 2,5, 3,7, 4,9, and 21, k. Okay, so I'm going to draw the arrow diagram that will help us here. So let's say x here, and then we have y here. We're going to do this. Okay, of course you don't have to draw it. Once you understand what to do, you don't have to draw this, because the question is of course not asking us to do this. Okay, so the first numbers, these ones, the first ones that we have, 1, 2, 3, 4, and 21. We are going to put them here. 1, 2, 3, 4, and 21. And then this side we are going to have the other numbers: 3, 5, 7, 9, k. Okay, so this is what the arrow diagram would look like. Okay, we have this arrow diagram here. Now, I've just drawn it so that we can understand that 1 is mapped onto 3, 2 is mapped onto 5, 3 is mapped onto 7, 4 is mapped onto 9, just like we have here, 4 and 9, 3, we are pairing them. We have this relation here. And the first question says, find the function that describes the relationship. Okay? Remember the formula that we are given to use is this one here. Y is equal to mx plus c. So all we need in this formula is to find m and c. And then we have our equation. And so here's what we do. What we do is we are just going to start by finding m. Okay? So here's how we find m. So the first thing that you do is, for us to find m, we are going to subtract some numbers here. So we are going to subtract 5. You always start with y here. So you are going to subtract 5 minus 3 over, so this 5 here minus that 3 there. And then 2 minus 1, because 5 is mapped onto 2, or 2 is mapped onto 5 and 1. So you subtract 5 minus 3 over 2 minus 1. 2 minus 1. Okay, so you just pick any 2 points. So here we've subtracted 5 minus 3 divided by 2 minus 1. Don't do it the other way around. You always start with this number here minus this one. So we are going to have 2 over 2 minus 1 is 1, which will give us 2. So our m is 2. So since our m is 2, we now need to find what our c is. We now need to find what our c is. So we are going to get our equation, this one, y is equal to mx plus c. And then we'll pick one of these points that we have, that we are given. You can pick any of the points. So I'm going to use the first one here, 1,3. So we have 1,3. So this one is x, this one is y. So where there's x, you put 1. Where there's y, you put 3. So you're going to have 3 here where there's y. Our m is 2. Our x is 1 here, plus c. So 3 is equal to 2 plus c. And then we can collect like terms now. This 2 comes this side. And since it's a positive, it's going to be a negative number. So you're going to have 3 minus 2 is equal to c. Okay, so when you subtract 3 minus 2 here, you find that c will be equal to 1. 3 minus 2 is 1. So now that we have c here, and we also have m here, so in our equation, this equation here, we can now find the equation. We can say, therefore, y is equal to our m, which is 2. So we are going to put 2 here. We are going to have 2 and the x will remain x plus our c here is 1. So this is our equation here. Okay, this is our equation, and this is the first part of the question, number 1. And then for number 2, we are going to put it here. Number 2, we are going to put it here. So for number 2 here, once you have this rule, it's easy for you to solve. Okay, so you have y is equal to 2x plus 1, the one that you found. And so here, our k is on this side where y is. So we are going to put k where there is y. And then this k is mapped onto 21. So you are going to have 2 here, 21 there, plus 1. So you are going to have 2 times 21, which is 42, plus 1, which will give you 43. Okay, so it's not always that you have to do this. There are times when you just look at the equation and you find that it's easy to find the answer. Now here it's not easy, because when you look at this, here they've added 2. 1 plus 2, we have 3. Here 2 plus 3. So it's not easy. It means you have to do what I have done here. And this is what we are supposed to do for this part. Now let's go to functions now. Okay, so before we go to functions, I want us to do a recap. We just go back on the last part that we did. Okay, when we are given these ordered pairs that we have, they are called ordered pairs because they are paired. 1 is paired to 3, 2 to 5. Now, on the last part, we were finding the function which shows the relationship between these values of x and y. Now, when you have ordered pairings like this, the first number here is usually the value of x, and then y, x, y, just like that, x, y. So x is 1, y is 3, x is 2, y is 5, just like that. And so when we say find the equation here, we are just going back, we already found it. When we say find the equation here, we said you use the formula y is equal to mx plus c, this one here. And for you to write down this equation, you need m, which we usually call the gradient, and then we also need c, okay, which we call the y-intercept. So now here, what we do is you start by finding m. Just get any 2 points from here, any 2. Let's say 1, 3 and 2, 5. Okay, these 2. So for you to find m, you are going to subtract 5 minus 3. Okay, so you always start with the y values. Okay, and then divide this by 2 minus 1, which will give you 2 there over 1, which is 2. So m is 2. And then for you to find the c now, you are going to get any of these points, just one of the points. And for example here, I'll get 1, 3. Okay, let's say we put comma here, 1, 3. So we have x and y. And so in our equation, y is equal to mx plus c. We are going to substitute now. So our m is 2. Our y is 3. So we have 3 here is equal to m, which is 2. Our x is 1 plus c. So 3 is equal to 2 times 1 is 2 plus c. Correct like terms here, you are going to have 3 minus 2, and the 2 comes this side, is equal to c. So c is equal to 1. So now that you have c here, and you also have m here, this is our m is 2. So in our equation, this one here, we are going to replace m and c, and we are going to have to get our function. So therefore, y is equal to, where there's m here, we put the 2 there, and then the x remains plus, since the c is positive, we are going to have a plus here. So plus our c, which is 1. Okay, so this is what we have. And for us to find our k here, since we have x and y, it's always x and y. So where there's x, you are going to put 21 here. So you are going to have 2 times 21, which is 42, plus 1, you have 43. Okay, so this is a recap of what we did in the previous one. Now let's look at the functions now, an example on functions. Okay, so here's our question here. So we are saying, given that f of x, that's the way we read it, we say f of x is equal to 3x minus 2, okay? 3x minus 2, find a f of 0. Number 2 here, f of 5 over 3. And then number 3, f of negative 2, 1 over 6. And then b here, okay? B, find x if f of x is equal to 10. Okay, so here is a question that we have on functions. Given that f of x is equal to 3x minus 2, find f of 0. So we'll start with that same question, the first one. So we'll start by writing the function that we are given. This is called a function. So we'll say f of x is equal to 3x minus 2. So we need to see what to do with this 0 here. So now we have f of 0. So you can see by comparing these two that where there's x here, we've replaced it with a 0. So we are going to do the same this side. Where there's x, we are going to replace with a 0. We'll substitute. So 3 times 0 minus 2, which will give us 3 times 0 is 0 minus 2, which will give us negative 2. So f of 0 is equal to negative 2. And that is our solution for the first question, this one here. Okay, so we can go to the second question. Okay, let's go to the second question where we are going to do the same thing that we have done. Okay, so once again for number 2 here, the function we have is f of x is equal to 3x minus 2. That's what we are given in the question. And the question here says find f of 5 over 3. F of 5 over 3. So where there is x, you replace with 5 over 3. Here there's supposed to be x, but we've replaced with 5 over 3. So we are going to have 3 times 5 over 3 minus 2. Where there's x, you substitute 5 over 3. And so since this is a fraction here, you are going to write this one as a fraction over 1. And then you are going to have 3 times 5 here. You are going to have 15. 1 times 3 here, you have 3 minus 2. And then you can divide here. 3 there, 1. 3 there, you have 5. So you are going to have 5 minus 2. Okay, so which will give us 3. Okay, so if you come up with a question where 3 cannot go in there, it means you have to write this one over 1, and then you find the common denominator and you solve the fractions. But in this case, 3 can go into 15. So we've divided. 3 into 15 is 5. Okay, so for example, if you had the number like, let me just give a quick example, it's not here. If you have a number here, down here, if the number was maybe 2, let's say 2, and you have 3 times 5 over 2 like this, you are just going to multiply 3 times 5, you have 15 over 2 minus 2, and then since 2 will leave a remainder when you divide, you are supposed to write over 1 here, find the common denominator here, which is 2 times 1, which is just 2. Then you do this, 2 there is 2 is 1 times that, you get 15, just like that. So that is how you solve here. But in this case, since we can divide, the question is simple, just like that. Let's go to number 3. Number 3 is f of negative 2, 1 over 6. Okay, so the first step is to change this one into an improper fraction. So you are going to multiply, you are going to have, this is going to be equal to f of negative 2 times 6 is 12, plus 1 you have 13. So you are going to have 13 over 6, like this. And then now, this one here, 13 over 6, we are going to replace it here where there is x. So we are going to have f of negative 13 over 6 is equal to 3, this 3 here, where there's x, we do this, negative 13 over 6 minus 2. Okay, here's what we have. And then we can write this one over 1 here, but you notice here that 3 can go into 6. Okay, so instead of just multiplying here, it's better you simplify. You say 3 there, 1, 3 into 6, you have 2. And so you are going to have 1 times 13 there, you have negative 13. Over 1 times 2 down here, you have 2 minus 2 over 1. Common denominator. Okay, because when 2 goes into 13, it leaves a remainder. So we have to find the common denominator. So the common denominator is a number in which these two numbers can go without leaving a remainder. So here, you just do 2 times 1 here, you get 2 here. Common denominator is 2. Then you are going to have 2 into 2 is 1. 1 times negative 13 is negative 13. Minus 1 into 2 is 2. 2 times 2, you have 4. Okay? Okay, so this is what we have, and then we can continue it this side. Okay, so here, since the signs are the same, just add the numbers on top. 13 plus 4 is 17. And then you maintain the same sign that we have. So you're going to have negative 17 over 2. And this is your answer here, because 2 can be divided in there, but it will leave a remainder. And then we now go to the last question. The last question. So here is our last question. So the last question says, find x, this is B. Find x if f of x is equal to 10. Okay, find x when f of x is equal to 10. Find x when f of x is equal to 10. Okay, so for this one here, we are going to write our equation, the function we are given in the question. The function is f of x is equal to 3x minus 2. Here it is. It's still here. And then what we have is f of x is equal to 10. Okay, so this time we are not going to replace this x with the 10, no. But instead we are going to remove this and replace it with 10, because we are told that this one is equal to 10. So we are going to have 10 here is equal to 3x minus 2. And then we can collect like terms here. Okay, this one and this one. So since it has a negative, it's going to be a plus this side. So 10 plus 2 is equal to 3x. So 12 is equal to 3x. And then we divide by 3 both sides. So over 3 over 3. And therefore, our x is equal to 4. And this marks the end of our lesson. Thank you.